Let's be honest, generative AI is completely changing the game in every single industry. And if you want to stay ahead of the curve, you have to speak the language. So whether you're trying to land a new job or just want to use AI better in the one you have, knowing the vocabulary isn't just a nice to have anymore, it's absolutely essential. In this explainer, we're going to break down 50 key terms that will make you fluent in the world of Gen AI.
So, here's how we're going to tackle this. We're going to use a building blocks approach. We'll start with the basics, the foundational architecture. Then we'll get into how these models actually learn. After that, we'll look at language models and how they perform, then dig into how we talk to them through prompting, and finally, we'll pop the hood and see how the core technical stuff really works.
All right, first up, Chapter 1, Intro to AI and Architecture. Think of these first few terms as the blueprints, right? These are the fundamental concepts that really define how these intelligent systems are designed and how they actually operate.
Let's kick things off with an agent. Now, an agent is an AI that can use tools and take actions all by itself to reach a goal. A perfect example is an automated travel bot that goes and books your flights and your hotels for you. For businesses, this is huge. It means automating really complex workflows. Next, we have alignment. This is all about training a model to make sure its behavior actually matches what we humans want. Think of a healthcare chatbot giving safe, accurate advice. That's good alignment. And this is crucial for building trust. Then there's attention. This is a cool mechanism that lets a model focus on the most important parts of whatever you feed it. In language translation, for instance, it helps the model figure out which words give the sentence its real meaning. It's what makes modern AI so nuanced. Fourth is BERT, a famous model from Google that's all about understanding language. It's one of the things that helps power Google search so it can grasp the full context of what you're asking, not just a few keywords. And to round out our first five, we have bias. This is a systematic error that creeps into a model's output because of flawed training data. A classic example is an AI recruiting tool that starts favoring certain candidates because of biases in the data it learned from. For any business, finding and fixing bias is key to getting accurate results and avoiding risk.
Okay, let's keep going with our foundational concepts. First up is chain of thought prompting. This is where you ask the model to literally show its work, to explain its reasoning step by step. So if you ask an AI to solve a tough math problem, seeing its process makes the answer way more transparent and trustworthy. Then, of course, there's ChatGPT, OpenAI's chatbot that everyone knows. You probably use it to draft emails or brainstorm ideas. Now, a key concept that makes tools like ChatGPT work is the context window. This is just the amount of information a model can remember and process at one time. A small window is like analyzing a single text message, but a large one can digest a whole 100-page report. This is a total game changer for business analysis. Next is the decoder. This is simply the part of the AI that generates the final output. In a translation tool, it takes the encoded meaning of your sentence and writes it out in the new language. And finally, we have the diffusion model. This is how AI creates things, like images, by starting with random noise and slowly refining it into something coherent. Every time you see a wild image from Midjourney or DALL-E, you're seeing a diffusion model in action.
On to Chapter 2, Training and Fine-Tuning. Look, an AI architecture is just a blueprint, right? It's pretty useless until it actually learns something. This section is all about that learning process, how we take a generic model and make it smart, and eventually make it a specialist.
First up, embedding. This is basically a way of turning data into numbers so that the AI can understand its meaning and relationships. An e-commerce site uses this to know that sneakers and running shoes are really similar, which is how it gives you those smart recommendations. Then you have the encoder. This is the part of the model that takes your input and turns it into a representation the AI can actually work with. So when you ask a chatbot a question, the encoder is the very first thing that gets to work. But how do you know if it's doing a good job? Well, that's where evaluation comes in. This is just how you measure a model's performance. For a spam filter, this means testing how accurate it is. Businesses rely on evaluation to know if their AI tools are actually working. A related technique is few-shot learning, where you can guide a model with just a few examples. You could give an AI just 3 support tickets that you've already categorized, and it can learn from those to classify all the new ones that come in. And all of this can lead to fine-tuning. This is where you adapt a big pre-trained model on your own specific data, turning a general AI into a highly tuned specialist on, say, your company's internal documents.
So fine-tuning gets us thinking about the models themselves and how they behave. The journey usually starts with a foundation model, like GPT-4. These are massive models trained on incredibly broad data, which makes them reusable for all sorts of different tasks. Their main function is generation, creating brand new content, like asking an AI to write an original poem from scratch. And that brings us to GPT, which stands for Generative Pre-trained Transformer. This is the family of models that powers tools like ChatGPT. Now, to make these models reliable, we need something called grounding. This just means tying the model's output to real, verifiable sources. An AI research assistant that gives you citations with its answers is much more trustworthy, because without grounding, you risk hallucination. This is where the model just makes stuff up that sounds plausible but is totally false. An AI inventing a fake legal case to support an argument is a perfect and pretty scary example of hallucination, and a serious risk for any business.
All right, on to Chapter 3, Language Models and Performance. We've talked about how models are built and how they're trained. Now let's zoom in on the models themselves, and, more importantly, how we measure how well they actually perform out in the real world.
Let's start with inference. This sounds technical, but it's super simple. It's just the process of running a trained model on new input to get an output. Literally every single time you use a chatbot, you're performing inference. To make inference better, we use instruction tuning. This means training a model on tons of instruction and response examples. You know when you say, explain this like I'm 5? That works because the model has been specifically tuned to follow those kinds of instructions. The models themselves are often LLMs, or large language models. These are the massive models trained on text that can understand and generate language, like Llama 3 or Claude 3. A really key performance metric for them is latency. That's the delay, the time it takes to get a response after you hit enter. For something like a real-time customer service bot, you need super low latency. And finally, LoRA. This stands for low rank adaptation, and it's a super efficient way to fine-tune these huge models. Honestly, this one has a massive business impact because it makes customizing AI so much cheaper and faster for everyone.
Okay, let's really peer inside the model now. It's all built on what we call model parameters. These are the internal values, or knobs, that the model learns and adjusts during training. You can think of them as the model's accumulated knowledge. Its brain, really. Some of the most powerful models are multimodal, which means they can handle more than one type of data at a time. Think of GPT-4o being able to look at an image and describe it to you in text. At the heart of all this is the neural network, a computing system that's inspired by the structure of the human brain. It's the core technology behind pretty much all modern AI. This is what enables NLG, or natural language generation. That's all about producing human-like text from data, like auto-generating a financial report from a boring spreadsheet. And the other side of that coin is NLP, natural language processing, which is about understanding human language. Things like spam filters, or tools that analyze the sentiment of customer reviews. That's classic NLP at work.
Okay, Chapter 4, Prompting and Optimization. Having a powerful AI is one thing, but getting it to do exactly what you want, that's a whole other ballgame. This is where the human element comes back in. It's a real skill, and it is all about the prompt. One way to guide an AI is with one-shot learning. This is where you give the model just a single example right there in the prompt. For instance, you can show it one article and the kind of headline you want, and it'll apply that same style to a new one. But you have to be careful of overfitting. This is where a model basically memorizes its training data too well, and then it completely fails when it sees new unfamiliar data. A related term is parameter, which is just a configurable value, like a setting you can adjust to change how the model behaves. Now, the input we give the model, that's the prompt. And the actual skill of designing that input to get the best result, that's called prompt engineering. So a simple prompt like write about sales isn't great. A well-engineered prompt would be something like, acting as a sales director, write a motivational email to the team about hitting our Q4 targets. See, that extra detail makes all the difference.
Building on that, let's look at some more advanced techniques. There's RAG, which stands for Retrieval-Augmented Generation. This is a clever way to make answers better by having the AI first go look up information from an external source. So a customer service bot using RAG might quickly pull up the official product manual before it answers your question just to make sure it's accurate. This is often trained using reinforcement learning, where a model learns from getting rewards and penalties, a lot of the time based on human feedback. The R in RAG stands for retrieval, and that's just the process of fetching that relevant data. Another important technique is sampling. This is how the model chooses the next word when it's writing, and it controls the balance between being creative and being predictable. And what makes all of this possible is the magic of self-attention. This is a mechanism that lets a model weigh the importance of different words in a sentence. It's the secret sauce for how it understands grammar, context, and all that nuance.
And that brings us to our final chapter, Technical Mechanics and Data. We are going all the way under the hood now. We're going to look at the fundamental nuts and bolts of how these AI systems actually process language and data.
First up, semantic search. This isn't your old-school keyword search. This is searching by meaning. So a search for clothes for cold weather that returns winter coats and thermal underwear? That's semantic search in action. Then there's temperature. This is a parameter you can tune that controls randomness. You can think of it as a creativity dial. Turn it down for focused, predictable answers, and crank it up for more creative, sometimes wild responses. The basic unit of text that an AI sees is a token. A token can be a whole word or sometimes just part of a word. And the process of breaking text down into these little pieces is called tokenization. It's the very first thing that happens when you send a prompt. And finally, there's top P. This is another one of those sampling parameters that controls randomness by limiting the model's word choices to only the most likely options.
And here we are, the final pieces of the puzzle. First, the transformer. This is the revolutionary architecture that is the foundation for almost all modern LLMs. It is the engine that kicked off this whole Gen AI boom. Next, tuning. This is the process of adapting a big foundation model for a very specific task. This is how businesses take a generalist AI and turn it into a bespoke expert, giving them a real competitive edge. At a deep mathematical level, meaning is represented by a vector, which is really just a long list of numbers. The words king and queen, for example, have very similar vectors inside the model. The set of all the tokens a model knows, it's its vocabulary. And last but not least, zero-shot learning. This is a model's incredible ability to perform a task it has never explicitly been trained on, with zero examples based only on the prompt you give it. It's a true sign of a model's generalized intelligence.
So there you have it, from agent all the way to zero-shot learning. We've gone from the basic architecture to the deepest technical mechanics. What you have now isn't just a list of words, it's a toolkit. The language of AI is the language of innovation today. You now have the vocabulary. So the only question left is, how are you going to use it to build the future?